All right, so finally, this brings us to the last question on this sample final exam, question 11, and it's a little bit of a thinking question. So it asks us to come up with a piecewise function that's defined everywhere except at 2 points, x equals -2 and x equals 4, and these are the points where the behavior of the piecewise function changes. We're also told that the limits from the left and the right should exist in both cases, both as x approaches -2 and as x approaches 4, but that the full limit should only exist as x approaches -2. So that means that in the case of x equals -2, the left hand and the right hand limits, they're going to need to equal each other. That's how the full limit will exist. But as x approaches 4, those one-sided limits will have to be two different values so that the limit as x approaches 4 doesn't exist. And there are lots of ways that we could approach this problem. There are lots of piecewise functions that would satisfy all of these criteria. And so we'll try to keep things as simple as possible. And so if we're coming up with a function, a piecewise function, that obeys all of the requirements that have been set to us, well, we know that the behavior is going to change at -2 and at 4. And in order to satisfy this first requirement, that the function not be defined at x equals -2 and x equals 4, that really just suggests that we're going to have strict inequalities at those points. So in other words, we'll have some definition that we'll come up with now in a moment, and that's going to work for all x less than -2, but strictly less than -2, so that x equals -2 isn't included there. And then we'll have some second definition, and that's going to work for all x bigger than -2 and less than 4. So again, -2 isn't included here, and neither is 4. And then some third definition, and that's going to work for x strictly bigger than 4, so that 4 isn't included in that one either. So we've got no definition at x equals -2 or at x equals 4. So that will make sure that, as we're required here, the piecewise function is not going to be defined at those 2 points. And we've set it up, as long as we have 3 different definitions here, the function will definitely exhibit different behavior on either side of each of those points. Now, we do want the piecewise function to be defined everywhere else. So we're going to want to avoid parts of the piecewise function here that could be undefined. So we don't want to have rational functions where we'd have to worry about the denominator becoming 0. We don't want to have trigonometric functions, square root functions, logarithmic functions, where maybe there could be asymptotes and things like that. And in fact, really, we want to keep this as simple as we possibly can. So we don't want to get into unnecessarily convoluted functions. So we want nice constant definitions, linear definitions, maybe quadratic definitions if we absolutely must, but probably not anything beyond that. And while we're not told to sketch the graph of this piecewise function, I am going to do a little sketch as we go here, just to provide a little bit of a visual justification for what we're doing. And let's start at the left with what definition we might choose for x less than -2. So we know we're going to want to set this up, first of all, so that the limit as x approaches -2 from the left exists. So we're not going to have a vertical asymptote or any weird behavior like that as x approaches -2. And frankly, the simplest way to do this is to just have a constant function there. And if we want this constant function to be approaching x equals -2, why don't we just use the constant function equal to -2? So visually then, this would exist down here, up to but not including x equals -2. So we'd have a hole in the graph right there. But otherwise, it'll be a nice constant flat function at a height of -2. And of course, that would mean that the left-hand limit as x approaches -2, that would exist and would be equal to -2. And then, as we've already observed, these are all strict inequalities, which is why I've already drawn in the little hole there at x equals -2 to show that the function's not defined there. And then we want, on the other side of this hole, we want the graph of the piecewise function to pick up right from that spot so that the left-hand and right-hand limits are both equal. And so we can't use the same constant function because we've been told that the behavior changes. So if we can't use a constant function, let's use a linear function. We want a linear function that's going to pass through the point -2, 2. So why don't we just use the function y equals x, which goes like this. That certainly satisfies the requirement. Now that the right-hand limit, as x approaches -2, that's also going to equal -2. So the full limit, as x approaches -2 of the function, yes, that will exist. That will equal -2. Now, let's turn our attention to x equals 4. So over here. Well, we've already set up now that to the left, the function's looking like y equals x. And we also know that at x equals 4 itself, so when normally this line would reach a height of 4, that's where the function becomes undefined again. So we're going to have a little hole in our graph at that point, like that. But then we want to set up so that on the other side of x equals 4, the function doesn't just pick up where that leaves off, because now we don't want the limit to exist. So again, let's go back to a constant function, but let's make sure we pick any constant function other than x equals 4. Let's pick x equals 3. Because then that would jump down here, and then the function would just continue off like that. But the way we've got this set up, from the left as x approaches 4, we've got the limit of the function being equal to 4. But from the right, we've got the limit as x approaches 4 of the function being equal to 3. Or I could have picked a different constant. Really, again, anything except 4 would do the trick. So that tells us that the limit as x approaches 4 of f of x, the full limit, does not exist, which is what we wanted. And so this satisfies all the requirements that have been given to us. With this definition, this is one way to get the function defined everywhere. Constant functions and polynomial functions are certainly defined everywhere. We've made sure it's not defined at -2 or at 4. We've made sure that the left-hand limits and the right-hand limits, as x approaches -2 and as x approaches 4, they all exist. But we've also made sure that the limit as x approaches -2 exists, while the limit as x approaches 4 does not. And there we go. There's question 11, and there is that entire sample final exam. I hope you found this useful, and I wish you the very best of luck in your Math 1000 exam. Have a great day.